Okay. What number do we want to do?
13. No. 12.
We start with, yeah, 12.
Oh, that's fine. We're good.
Actually, I was looking at it and it kept telling me the angle's like 45. And this telling me,
Where's my black marker? Gone into the ether.
Looks like we're using brown today.
Or I could pull out another black one.
Or we can do that.
I ran out of pencil, but I don't know where mine is.
I started using the normal pencils again. They work better for me.
You could do like your brother and sharpen it every 2 seconds.
I'm like my brother.
No, I said you could be like your brother.
I'm fine with it being like blunt. I don't really care.
My mom wants all her pencils to be sharp all the time. And all the whole pages. It's like, how can you write? It's like, the lead is still thoroughly out of the wood.
Yeah. I have a really nice pencil sharpener at home that makes them so sharp. 0.1 millimeter.
All right. We are asked to find a suitable angle of rotation and do it. Write the equation in standard form. Great. All right, so we got to figure out the angle. That's the word.
Start with the cotangent. 2 theta A minus B over C. And A minus C over B.
Is this the double or the half angle I did? Because that's happening here.
Yeah.
Well, it's about to be, yeah.
So what is this then?
This is the formula that gives us the angle.
Oh, okay. Angle.
All right, what do we need now?
So plug stuff
Do
in.
it.
Plug what in?
The A and the C and the B.
All right, what's A?
1.
What's C?
1.
What's B?
-1.
Angle 0?
Yes. Yes, because the top equals 0.
The cotangent to theta equals 0.
And then we do the half angle identity.
Half angle identities. What's the identities we're looking for?
Sine equals square root of 1 minus cosine 2 theta over 2.
Wow, you read that so fast. Sine theta equals
1 minus cosine 2 theta over 2. And cosine equals square root of 1 plus cosine 2 theta over 2.
1 plus cosine?
Yes.
Over 2. That should
You
work.
have to find, we draw a triangle, right? To find the 2 cosine 2 theta.
I feel like we're a little off. Aren't we a little off?
How?
What do we do wrong?
What do we do wrong? Like, opposite next stepwise?
No, we're not. We're good. All right, what do we do?
Triangle. Cotangent is adjacent over opposite. So is it 0 over 0 or is it 0 over -1? Just 1.
Well, so for 0 and 1, it's maybe a little bit easier to think about it with the chart than with a table. Because we want to know where, well, I don't know. I'll shut up. We'll keep going.
Well, get us the hypotenuse is 1.
Yeah. Because this really isn't a triangle, right? It's just an up and down line, yeah?
So then a 0-degree angle for cosine is 1.
And actually, well, it would be -1, right?
Yeah.
But that's still 1. Yeah, so it's even drawn upside down. But, okay, so the cosine of 2 theta would be adjacent over hypotenuse. So this would equal the square root of 1/2. And this would equal the square root of 1/2.
Maybe -1/2 on the bottom? Or the top? No, there's 1.
No, it's 1 minus 0 is still, yeah. So they're both the square root of 2 over 2. So what's the angle then?
That came from just like simple.
Pi over 4.
Yeah. Rationalize the denominator because square root of 1 over square root of 2, multiply square root of 2 over 2. Yeah. So the angle we are looking for is pi over 4
How'd you get that last pi over 4 number?
from the chart.
Oh, yes. Yeah, that's, yeah.
Okay.
That's what we plug into the term, which is like x equals
Yep. X equals what?
x prime cosine minus y prime sine. And then y equals x prime cosine x equals plus
Wait,
y
x prime sine
cosine.
minus y prime cosine? Yes.
All right. So something like that. What is the sine of pi over 4?
Square root of 2 over 2.
Yeah. They're all square root of 2 over 2. All right. So equals x prime square root of 2 over 2 minus y prime square root of 2. And y equals x prime square root of 2 plus y prime square root of 2 over 2. Then we shove it into that thing.
This one's nice.
Oh, you did. Okay, I see.
All right. Square root of 2 minus y prime square root of 2 over 2 quantity squared minus x prime square root of 2 minus y prime square root of 2 over 2 times x prime square root of 2 plus y prime square root of 2. This one, at least, actually is conjugate. It actually is conjugates in the middle. Plus x squared, no, x prime square root of 2 plus y prime square root of 2 over 2 quantity squared equals 2. So we square out all this mess. We end up with x prime squared times 2 minus 2x prime y prime times 2 minus x prime, no, 2x prime squared plus 2y prime squared plus, same thing as that with a plus in the middle. Wait, I missed the whole term, didn't I? At times I did. Not enough room to squeeze that in right there. Y plus 2y prime squared. This one.
Why is it plus 2y?
Because the last one squared would be square root of 2 squared, which is 2, and times y squared, y prime squared, which is y prime squared. This is the middle. This is the middle one.
Okay, yeah.
Yeah. Plus 2x prime squared plus 2x prime y prime times 2 plus 2y prime squared. All of this stuff over 4 equals 2. Multiply 4 on both sides, and this one and this one are opposites, so they do cancel. Looking good for our success.
When you're multiplying two square roots together, the square roots are always going to cancel.
Well, yeah, if they're the same.
So, yeah,
Yeah,
because then that would be the same.
yeah. If it was like square root of 6 times square root of 3, that would be the square root of 18.
Okay.
But yeah. All right, so we've got 2x
Why
prime
isn't the one in the
squared.
parentheses a minus? 'Cause it's a minus
The
sign plus.
one in the,
The parentheses, there's the middle sign.
yes, it should be a minus. I was thinking ahead of distributing the 8. Just kidding. Okay, plus 2y prime squared minus 2x prime squared minus 2y prime squared plus 2x prime squared plus 2y prime squared equals 8. How we doing?
Correct.
How you doing, Garrett? Making sense?
Yeah. This last part makes sense. It was just the beginning that I had no idea what to do.
Gotcha. Then some of the stuff's gonna cancel. This one with this one and this one with this one, leaving us just that, which means it's a circle. We can also divide by 2 because it's a circle. We may as well do that. And we're left with x prime squared.
You just said you needed to multiply or distribute the negative.
Oh, and I did, and then I didn't. So it's not a circle because this one doesn't cancel with this one, but the x's do. So 2x, we'll deal with dividing by whatever in a second because I think we're going to need to do that because it's, well, we're definitely going to need to do it because it's going to be an ellipse. So 6, yeah, plus 6y prime squared equals 8. It's an ellipse, so just kidding, divide everything by 8 instead. And end up with x prime squared over 4 and 3/4 divide by 4/3. That's really what we wanted to do. Let's walk it all out. Okay, so plus 3y prime squared over 4 equals 1.
Why are we dividing by 3/4?
6/8 reduces to 3/4. But that's not really what we want because we want all that 3/4 in the denominator, right? So how do we make all that 3/4 be in the denominator?
Multiply it times 4/3. By 1/3?
You do 1/3, yeah. So you're both thinking right. So 1/3 over 1/3, which would be turning this into, so you're just flipping the fraction over, which would be 4/3, right? So x prime squared over 4 plus y prime squared over 1 1/3, which is ugly, but you know, it's an ellipse, so what do you expect?
Okay, explain to me that last step where you're doing that 1/3 thing.
We don't want that 3 up here. We don't want to write it that way.
Okay.
Right? So there's two ways to think about it. You could think about it as we're multiplying the top and bottom times a third. 1/3 times 4 is 4/3, which is the same as 1 1/3, right? Or you can think about it as we're just taking this fraction and we're flipping it over to be 4/3, which still turns into 1 1/3.
Okay.
And
Your
then,
goal is just to get the,
are we supposed to do anything else with this problem?
besides write the ellipse and circle it? I don't know.
Let me see.
I think we're just supposed to write it in standard form.
Oh, okay.
Great, we did it.
We do 14.
These, one problem takes up a whole page.
Yeah.
So 14?
Yeah.
14.
Where's my extra pencil at? I cannot find it.
It's crazy. 14's got all kinds of crap in it. And it ends up really simple.
No, I was didn't figure out how to do that. Mine was not simple.
What is the next unit? Is it, yeah, vectors. Trying to, I've been thinking a lot about it and haven't decided fully. I'm trying to decide what to do with the rest of our semester. How to finish the semester.
3 weeks left.
Correct.
2 weeks until midterm.
Well, we have 4 weeks, including this week. Yeah. So 14. We have 6x squared. Or is it 16? Yeah. Minus 24xy. Plus 9y squared. Minus 5x. Minus 90y. Plus 25 equals 0.
Computer's dying.
There's like, that's all that's left, and I can't have none. Usually I take stuff out of my other pencils.
All right, what should we do?
Is this like one of the completing the square ones, or is that?
Who would like a mechanical better?
So you could maybe get somewhere by doing some completing the square, but you're still going to have to deal with the xy term, right? So we still have to do some rotation stuff.
Do the cotangent with, or how much of it even if I wrote it for the x's to be together and the y's to be together?
What about the xy?
It's in the middle.
It was in the middle.
I don't know.
And then he did some completing the square nonsense
Well,
or something.
no, I think that was a different guy that wasn't doing the same thing.
I see.
Would we do the cotangent thingy? Yeah.
It's probably true. What's A?
16.
16 minus 9 over 20, negative 24.
So 7 over negative 24.
7?
Is 16 minus 9.
Negative 7. No,
Yeah.
I was right to begin with.
Okay, so then,
Triangle. 2 theta. The adjacent over opposite. And then 24 squared plus 7 squared equals,
Negative 24.
yeah, but what's negative 24 squared? Positive something, so who cares? Okay, fine, put the negative in there, make you feel happy. Same difference. What's 24 squared?
576.
That's not what I was going to guess. That's embarrassing.
7 squared is 49. What's 576 plus 49?
625, oh glorious day, that's an actual square. 25, thank the Lord.
Square root both sides, and we get C equals 25.
Oh,
It's almost like they planned it.
Oh,
It's almost like they planned it out.
almost like it.
So the sine of 2 theta equals negative 24 25ths. The cosine of 2 theta equals 7 over 25. Half angle identity says
Sine theta equals the square root of 1 minus cosine 2 theta over 2.
cosine of theta equals 1 square root of, oh my goodness, 1 plus cosine 2 theta over 2. So the sine of theta equals 1 minus, I don't know why I wrote all those. We didn't really care about all those, but that's fine. Minus 7 25ths, so 25 25ths.
With the 7 on the top and the 25 on the bottom.
What?
Like 1 plus 7 over 2 times 25. Could you write it like that?
I'm confused what you're saying.
Like move the 25 from the top and then move it just to the bottom.
And then multiply everything times 1/2. Yeah, same thing. But you got to do the addition subtraction first, like it's in parentheses.
I don't think we're saying it.
Maybe so. 25 minus 7 is something. 18 25ths. So 9 20. Imagine that. It's also pretty. Square root of 9 25ths. It's almost like they planned it. So it equals 3/5. Wow. Then
Just 4/5.
I believe you, but I'm going to walk it out anyway. Square root of 25 25ths minus 7 25ths divided by 2. Oh yeah, plus. We already did minus 1. That's crazy.
32 over 25.
32 over 25. Half of that is 16, so square root of 16 25ths, which is in fact 4/5. It's almost like they planned it. It's crazy.
Happy numbers. We love happy numbers.
It's crazy.
Halfway through the page. Almost.
I'm squishing.
Squishy, squishy, squishy. I need to remember to do that. Because I keep forgetting I need squish. And then we plug it into the x times x prime equals all that crap.
Oh, that's good. I'm glad that Brian is involved in this text thread because I didn't want to deal with it myself. Okay, now we need x equals x prime times cosine theta minus y prime sine theta, y equals x prime times the sine of theta plus y prime times the cosine of theta. So x equals 4x prime
times 3.
minus 3y prime over 5.
What? Times cosine.
Oh, because that's what it is.
Oh, I see. I got it now.
Y equals 3x prime plus 4y prime over 5. Now we start sticking it into that. Okay, here we go. 16 times. So tempted to, but that's probably a mistake. Okay. 4x prime minus 3y prime over 5 quantity squared plus, no, minus 24 times 4x prime minus 3y prime over 5 times 3x prime plus 4y prime over 5. Plus 9 times 3x prime plus 4y prime over 5 quantity squared minus 5 times, oh, that's crazy. Okay. X, so 4x prime minus 3y prime over 5 minus 90 times
I'm out of space.
3x prime plus 4y prime over 5 plus 25. That's hard. Equals 0. Ooh. Okay, so
This graph paper is not big enough to.
that's crazy.
Do 2 lines.
Huh?
Do 2 lines.
What's that? How to do it? I don't
16x prime minus 12 times 2x prime y prime, which is surely going to go away, plus 9y prime squared over 5. 25, yes. Minus 24 times, they're not conjugates, because of course they're not. So 12x prime squared plus 16x prime y prime minus 9x prime y prime minus 12 y prime squared over 25.
I'm so hot. I'm just doing the math.
Well, it is kind of hot in here. I need to turn the thing down.
Please.
Plus 9, no. Oh, that is squared. So yes, 9 times 9 squared plus 2 times 12x prime y prime, excuse me, plus 16 y prime squared over 25 minus 20x prime plus, actually, lies. Just distribute the negative. So minus 4x prime plus 3y prime. This also reduces to 1, and 5 into 90 would be 1, and then there's 3 left over, so 16.
1/16.
Well, 16 over 1, actually.
Oh, okay.
So negative 16 times 3 is whatever that is. 44, yeah, negative 48 x prime. Negative 16 times 4 would be negative 64 y prime plus 25 equals 0. Got like terms here. I'm going to distribute junk here. This one and this one. This and this and this. 16 times 16 is some big number.
256.
Yeah, I was thinking 200 something. I should have known 256. That makes sense. 256x prime squared. Forgot the squared. 16 times negative 24 is also a whole heap.
Sorry, what number?
Negative 384.
Negative 384x prime y prime plus 16 times 9.
144.
That is all still over 25. Minus 24 times 12x prime squared plus 7x prime y prime minus 12y prime squared over 25.
Why didn't we distribute the 20?
Because I just combined, because I didn't want to combine like terms and distribute on the same step. Seemed like a recipe for disaster. 9 times 9 is 81 plus 81x prime squared. 24 times 9 is what?
24 times 9. 216.
16x prime y prime plus 16 times 9, which is
16 times 9?
16 times 9.
Yeah, 144.
Over 25. We've got some like terms out here that we can deal with. This one and this one and this one and this one. So negative 4 minus 48 is negative 52. Right? And then 3 minus 64 is negative 61. All right. What are we going to do on this step? Let's combine like terms with this fraction and this fraction because they already have a common denominator, and we'll distribute that. So we're going to combine this with this, and this with this, and this with this, and we'll distribute this guy. That seem reasonable? Sure, why not?
I don't want to hear my sister telling me that she's mad that I get to use calculators ever again.
All of your sisters get to use a calculator in the math class now.
Yeah, my sister does now, but as of like 2 months ago, she couldn't.
All right, so 256 plus 81 is what? 300 and some odd. 337.
What did you say?
Does that sound right?
Yes.
I didn't hear what the number was.
This one and this one. And then negative 384 plus 216 is negative 168 maybe. Negative 384 plus 216.
Negative 168.
68. And 144 plus 144 is 290.
288.
Yeah, that. 288. Shouldn't that have a y prime squared on it, right? Yes, it should. Both of those. That's funny, I missed it on both of them. All that is over 25. Now let's deal with the distributing. So negative 24 times 12 is 288 negative x prime squared. Negative 24 times 7 had better be negative 168.
Negative 24 times 7?
Yeah. Oh, just kidding. It's not going to. Oh, no, we did.
No, negative 168. Negative 168.
It's 590. Oh, what did I do? Negative 20. Oh. Sorry. Sorry to scare you, Sean. Yeah, negative 168.
Except somehow it's negative and it should be positive. Because it's got to cancel. One of those should be positive. I made a sign mistake somewhere.
To be completely honest, when this happens to me, I know what it's supposed to be, and I know I made a sign mistake, so I just move on with my life with the right sign.
Well, yeah.
And
One of them should be positive. This is the middle, so 2, and yeah, negative that. And so that's negative. This one is positive. This one, this and this times this is positive. This times this is negative. Did I copy something down wrong? 24 plus 9 minus 5x minus 90 plus 25. I don't know why it's not, the signs aren't working right. I don't see any mistakes. Do y'all see any mistakes?
No.
Well, let's pretend like it was plus and let's see if it matches the key. So plus 168 x prime y prime. And then negative 24 times negative 12 is positive, what is it, 288? Y prime squared. Well, this is over 25. Oh, I know why. I know why.
X and Y.
It's because this minus shouldn't have gone there. It should have gone here.
Where?
Oh, we're multiplying negative 24 times. No. That's not right. That's not right at all. Negative 24 times that is negative this. Negative 24 times positive. Yeah, no. That's still negative. I don't know. But this one is, yeah, positive. Minus 52x prime minus 61 y prime plus 25 equals 0. So 337x prime squared minus 288x prime squared is what?
357 minus.
337.
337 minus
288.
49.
49x prime squared. Canceling those. 288 plus 288 be 500 and something.
Sorry.
576.
288 times 288.
Squared, that's over 25 minus 52x prime minus 61y prime plus 25 equals 0. So now what?
Oh, wait, how do I get rid of the thing in the middle?
What are you talking about? We made an assumption and we're going to see if it matches. That's what I said. Which if that assumption is true, then that 9 probably should have been a negative. It's probably where no, just kidding, the 24 probably should have been a positive is probably what, if it works out that way, which would make these numbers different.
And then great sadness and depression.
I'm wondering if that 24 is a typo and it should have been a positive 24, because I think that might have worked out right. We're gonna split the difference here. We're gonna pretend like that's true and write down what that would be. So if it was positive 24, then this would have been, let me grab a color. This one would have been plus, and this one would have been minus. So assuming that that's true, then what's 337 plus 288? I think this is gonna matter, because I think one of them does cancel.
625.
Okay, so 625 x prime squared, those would cancel at that point. These would also cancel at that point, right? So it'd be that over 25 minus 51 x prime minus 61 y prime plus 25 equals 0. So what would happen at this point on the purple one? I bet you anything that's where the typo is, because this is going to come out pretty-ish. Well, you could reduce this. What's 625 divided by 25?
Oh, 25.
Yeah.
Oh, I should
So 25x prime squared minus 51x prime minus 61y prime plus 25 equals 0. And then what would we do?
There's not really anything to combine.
Complete the square.
Oh, good idea.
Oh, yeah.
Oh,
I'm lost, so I'm just gonna follow.
Okay. Are you listening to me instead of doing your own thing now?
I am.
Okay, good. This is what we're assuming. We're guessing, the purple thing is a guess, that there's a typo in the book, and this should have been plus.
Okay.
That's where we are. Okay. So, to finish the purple one, we're going to complete the square, right? So, shove the x ones over and pull out a 25. Yeah. It's 25 parentheses x prime squared minus something annoying, right? Minus 51 over 25. Okay. Did these numbers match what you were having at the point, what everybody was having, the 50? Well, that should have been 52. For one, is what I have here.
I have 58 and 69.
Okay, let's see. Let's go back. Let's wind this one back, because these numbers don't sound right. Let's see. erase that before I get confused later. All right, so the 5 just cancels on this one. We distribute a negative. Turn this minus and this plus. 5 goes into 90 16 times, is that correct? 18, there's it. There is it.
Just figure out the problem.
Yeah. So negative 18 times 3 is 54. And negative 18 times 4 is negative 72. And then this would be negative 58. And then this would be negative 69, right?
Yes.
58, 69, 58, and 69. Okay, and 58 and 69. Still is ugly. We'll see what happens. Negative 58 25ths x prime. Negative 69 y prime minus 25 69ths equals 0. So negative 58 25ths times 1/2 squared is negative 58 50ths. Squared is something big and ugly. What is it?
841 over 625.
821?
41.
841 over
625.
625. 50 times 50. 50 times 50.
Oh, it's been reduced down from what the gigantic thing was.
50 times 50 is 2,500.
Yeah, and then that, yeah, okay, great. Then it reduces by whatever it reduces by 4 or something. Okay. I don't know. No matter what happens, this is because it doesn't, because we didn't see a mistake in the black, right? There's no that we didn't make a mistake that y'all have been able to see, have you?
No.
Okay, because it doesn't cancel with our work.
Yeah.
So it's either this or there's some other typo in the book. But this seems really ugly, so let's keep on going. Here we go. So plus 841 over 625.
And then you multiply that by 25 and you get to 841 over 25.
Yes. We're going to subtract 821 over 41 over 20, what, yeah, over 25.
Really? 625? No, because we have to multiply by the 25 that we took out from the box. Okay.
Equals 0. So this factors into, this is not what's in the book. So there's either other things in the key that are weird, or we made some mistake that nobody is catching.
I'm going to sue Texas Instrument, or what are those even called? McGraw-Hill.
Or we made a mistake. No, because we had to have made a mistake in the black because it should have worked even if the key is wrong. So we had to have made a mistake in the black somewhere. So we did make a mistake somewhere.
Yay.
But I don't know where that mistake is. And I don't know that you do either. And I'm saying the collective you.
I think I understand the idea. Can we keep going with what we would do once we got the
With the purple one or the black one?
with the purple? Because I just don't know what to do after you finish finding the
We would have to put this chunk back to this. And then we would still factor out a negative 69. And we would discover, okay, this is an ellipse. Actually, it's a hyperbola, right? So we have to make this into a 1 and all that other junk.
Yay.
And I can tell you, so paying very close attention, you will have one, a rotated conic. It will not be this ugly. It will exist, so make sure you study. And that will, so arguably on this test that's on Thursday, this problem, which there will be one of, will be the hardest problem on the test. Do not neglect to study the rest of the conics and all the other stuff because it'll lose out your ears. You may still use a note card on the test. That's totally fine.
Are we gonna be given the angle? We gotta find the angle.
You'll have one where you have to find the angle, like this, where you have to find the angle.
So there's gonna be two of one way, given the angle, one way we have to find it.
That remains to be determined, but there will definitely be one like this. Most of the rest is fairly straightforward, just like graphing parabolas, ellipses, hyperbolas, and circles. Most of the tests, with a little bit of studying, make sure you have your X's and H's and A's and B's straightened out.
All of that.
Well, as long as you have all that straightened out and this goes with this and this goes with that, the rest of the test shouldn't be that hard and should be easier to study for. So, you don't have any homework other than, study for the test. Goodbye.